Hello teacher. Hello Miss Huyền. Đâu là Miss Huyền đúng không nhỉ? Chứ vậy. Ok nha. Hello Miss Huyền. Welcome to our presentation. Today we are presenting on section 6. And let's start with a fundamental question. Does the order in which we evaluate the expression actually matter? The answer is it depends entirely on the type of language. If predictive language like C or Java or the absolutely matter, the language has side effect, meaning an expression that not should compile a value. It can also modify memory states. If you evaluate things in the wrong order, you get a completely different and incorrect result. And I have a simple example. If through subnet question both modify the same variable, the final result change depending on which one done first. And the instruction is the fundament of everything else in section 6.1. It explains why different language make such different design short error expression. Okay. And now that we understand the true work of expression evaluation, let's look at how different languages actually wise like expression. There are six major notation. First, in fix the most familiar, the operator sit between is operand like A plus B. This is used in C, in Java, or in Python, and prefix place the operator in front like of A, B. You can see this more often with an array operator, and postfix put the operator at the end like A, B of language like PostScript, and Forbes use it approach. And Cambridge Solid is a notation of list and skew. Everything you have in a present with the operator first like multiply, add 1 and 3 by 2. It look unusual at first, but it completely eliminates any ambiguous about prison. And we have mixed face, interleaves, keyword, and apparent like A display on B at C in small tag and objective C. And finally, we have the ternary operator in the compact shorthand for EPL. It means if you can see if A then B L C. It usually in C, C++, and Java. And the key takeaway here is the more imperative language you inflict for binary operator and prefix for unary unary ones, which is exactly what feels natural to other programmer. And even with a decision design, we still have a critical question when multiple operator appear in one operation with one gets evaluated first. Okay, this is where present and associativity come in and where language can go seriously wrong. On the present side, C and C++ define around around 15 lever of reasons that solve trouble, but in practice it makes a person very easy to mistrust and introduce hidden logic error. And on the associativity side, most operators are left to write a line, as you can see, like 9 minus 3 minus 2 give 4, not 8. Okay, but exponentiation in function is right to let meaning 2 to the power of 3 to the power of 2. It evaluates at here you can see uh, okay, and I have here something that surprise many new programmer. A variable doesn't always mean the same thing depending on where it appear. uh, The key insight is that context determine meaning. When a variable appear on the left side of an assignment is acting as an L value is representing a memory location. In A equal B plus C, we are writing to wherever A lives in memory. And when a variable appear in the right side is asking an R value, it represents the current value stored there in D equal A. Okay, we are reading the values as A currently hold. Okay, why does it matter? I think it's because in language like C, you can take the address of an L value with n, you can reference a pointer, and if you confuse the two concepts, you end up with a pointer error that are difficult to debug. Okay. And the next we have value and reference model boxing. Um, Different language have fundamentally different philosophy about what a value variable actually is. In the variable model, you by C and Pascal, a variable is a container is how data directly. When you assign one variable to another, you copy all the bit, okay, simple, very simple and predictable and easy. But in the reference model, you in Python lists and LM. A variable is just a name pointer to an object living on the heap. Okay, not a bit. Assignment doesn't copy the data. It should make the variable point somewhere new. So variable can easily end up pointing to the same object, which have important consequent formation. Uh, and the next, you have some problem with orthogonality and advanced assignment. Assignment is something we use constantly, but not language often more powerful form of it than just the basic like A equal B. Okay, orthogonality refer to the idea that language feature can be freely combined. Our 68 pioneering here. Every statement including assignment return a value. C and C++ in here to this week you can write something like um, assign x. Yeah, in the slide you can see a sign x is a result of getcha, then compare to EOFs. This assignment happened inside the condition. And multi-way assignment in Python is extremely impressive. You can assign multiple variable as one. So up to values which are the temporary variable or unpack a tuple return from a function or on in the single and clean line. Combination assignment might look like short a shorthand, but it had a real functional difference. Consider A of F, A of function E equal A of function E multiplied by E is versus A of function E multiplied by E. In the first version, function E equal twice is true. Okay, if the function had a side effect like printing to the console or implementing or counter the side effect, what will happen twice? Computing the result and the combination assignment ensure if function E is invalued exactly one, and the perfect example of how similarly minor syntactic difference can have the real behavioral consequence. Okay, and I have in initialization and evaluation orders and sort. short-circuiting problem. The more critical topics that shape how expression behaves at runtime. Unity or relation is about ensuring variables have a value before they are used. Java and C Sharp in 45 assignment, the compiler statically checks that every variable is assigned on every possible code part before it reads, okay, and if not you get a compile time error. And a more dynamic approach to is to initialize variable with signaling like noon, like na n a special floating point value that trigger a hardware check immediately when a shape marking an entity. Those line accept error easy to cut at runtime. Evaluation order in evaluation order subtle but important decision. C and C++ deliberately leaves the order of sub evaluation undefined, giving the compiler freedom to optimize register uses. And in Java, on the other hand, is strictly for less to write evaluation for predictability. And short the circle and the next is a short circle evaluation is a practical optimization with real safety in implication. When evaluating a Boolean expression, is a result is already determined from the first operand. The second operand is never evaluated, and the compiler implement which is some code rather than actually computing true or false value. This let us drive safe pattern like you can see like P and P or key not equal var and D equals 0 or N divided by D less than 10. And the next problem is applicative order or normal order evaluation. Uh, we react one of the most fundamental design question in language implementation. When exactly do we evaluate the function agreement? First, applicative order evaluation mean argument only evaluated before being passed into the function. The before in virtually every mainstream language like C, Java, and Python, and normal order evaluation takes the outstep approach argument part into the function in the an evaluation form essentially at expression, and the function only evaluates them if and when it actually needs them. This is powerful for working with infinity data structure since you never compute more than you need. And the an anatomy of normal order error in C parrot macro, C parrot macro are actually a real world example of normal order evaluation hiding inside an otherwise applicative language, and they demonstrate exactly why it's dangerous. Macro though does not compute anything, but they can simply perform textual substitution before compilation. This means all the nature of normal order apply. We have three problems here. Problem one is impossible recursion, and problem two is precedent error from textual expansion, and problem three is double side effect. And we have a next problem Here is parameter for local variable name class consider zip swap macro. You can see in the slide, they look perfectly reasonable, but it's a programmable called function swap xt it append to here. The local variable t inside the macro shadows the t that were passed as an argument. The result is that it get assigns the value of the macro internal t with it itself, and then the internal t is shared to itself. Nothing gets swapped. This is a server logic error in the compiler we not got. And the next we have lazy evaluation, and we have seen that applicative order is fast, but it is very inflexible, and normal order is flexible but percent potentially slow and dangerous. Lazy evaluation is a strategy that tries to get the best of both worlds. The idea is illusion by evaluating an operation until its value actually needs should lie normal order, but the moment it is evaluated as a result, if the same operation needs again returns the cut value instead of recomputing it, the cut equal memorization. Yes, this makes lazy evaluation incredibly powerful for stream processing. Infinity square and any situation where you want to define what you want without specifying how much of it to compute upfront. And the next and the next we have strict evaluation is scale to really I can say that to really appreciative why lazy evolution is this. Why lazy evolution is it? Let's look at that happen when you try to build an infinity structure in a strict language like Scheme. Unlike Haskell, Scheme you apply creative order evaluation by default. This means when you call a function or argument are fully evaluated before the function body run. You can see in the slide, if you try to define an infinity list of natural numbers the same way you use in hardcore like this, yeah, this immediately gets stuck in an infinity recursive loop before it can even return a single element. Why? Because Kimi tried to fully evaluate neck of and plus one before passing it to cons. That trigger another call, which trigger another forever. The solution Kimi provide is a delay for the mechanism, wrapping an operation in delay creep, promise, defer a compensation that is not evaluated, evaluated just calling for on the promise evaluated is and return the result. And in our session 61, we have our last problem is called implementation of delay and force. And finally, let's look under the hood at how delay and force are actually implemented, because getting it wrong leads to serious inefficiency. The nice implementation define delay as simply wrapping the expression in a lambda, a function with no argument. Okay, calling for should involve that lambda it work, but it had critical flow. Every time you call for the expression evaluated from trap, this degraded to normal order evaluation with all it in efficiency problem. The correct implementation introduce a memorization layer. The key idea is to maintain true internal key of state of first. Class that start as true and variable that start as empty. The first time for equal. It evaluates the expression, stores the result in var, and prefer to for, and every subsequent could go to for on the same premise. See that first in a for and simply return to the cut var. No recomputation at all. Okay. So that wrap up section 6.1. We have covered how expression are written and how they are evaluated, evaluated and the deep trade-off between evaluation strategies and in the next in section 6.2 we will move up on lever or look at how the expression are organized into larger control structure like selection, iteration, or an recursion. Okay.
We now move to the second major topic, structure and unstructured control flow. Uh, this cover uh, this cover how program design with path to check how the repeat operation and the critical historical depends around the Goto statement. The Goto statement was one standard tool in programming. First, it's become infamous for producing what is called spaghetti code program. So Tango and a bit cherry jumps that they nearly impossible and with also to reach or maintain the structural the struct the structural programming movement championed championed by Disha as is the bit what is now the ultimate rule avoid Goto. The argument was proved correct. Algor- every algorithm can be expressed using just three concepts: uh, focusing, selection, and iteration. Within structural flow, there are still performance considerations. The The switch statement is typically faster than a long XL chain. The for loop can sometimes be combined, uh, combined more if, efficiently than while and recursion, as we mentioned, and is more express, expressive and general than iteration. Uh, Uh, let's look more close, closely at how selection structure work under the hood. Uh, a, multi-way XL chain is usually combined into sequential conditional test. If you have 20 branches, they would create 20 comparison before hitting the right one nearly time, nine near time. Uh, the switch uh, the switch statement is specifically designed to let compiler choose the best implementation strategy for maximum speed. There are four common strategy. Uh, example is the fastest. It requires only a single lookup of how many cases there are. Uh, the check of is memory consumption, which can be large if the key value are wildlife spread. Uh, a head table is extremely fast for like discrete value but more complex implement. The key design principle principle is that switch structure give more compiler freedom to pick the optimal strategy. Sometimes a chain if a chain of if statement cannot do. We have iteration structure. There are two main category of loop structure. Uh, e- enumeration, enumeration controller loop and logically controller loop. Enumeration controller loop like the transitional for loop. The rate iterate over each element is a now fi- finite set. The number of iteration is determined in advance. Logically controller loop like while and do while execute until a pooling condition change. The iteration count is not know ahead of time. They they more flexible, but they have overheat because uh, they condition the condition must be evaluated at the start of every iteration. Uh, there also a hybrid concept called the mid loop test or the a half loop. Instead of checking the exit condition only at the beginning and or end, you use break or exit statement placed inside the loop body. Iterator and generator re, represent one of the most practical and elegant concept in a modern programming. An iterator provide a clean, uniform way to traverse and sequence of elements without needing to know anything about how the sequence A is generated. In C++ element, the red base for loop with with auto is visible behind the scene. The computer automation automatically generates uh, an iterator object and connect function for you. Generator with Python support natively with the Zio keyword. Take it even further when the generator function hit a Zio statement, it returns a value and suspends itself, remembering its entire internal step. The next time it's called, it's big, it's picked up exactly where it left off without restarting. This make a incredible, incredibly easy to generate complex sequence like a string of a given length over alphabet as so in our example. Uh, recursion and tail recursion. recursion is foundation, foundation, founda- foundational concept in programming language theory. Any iterative produce can be rewritten and recursive form, but more importantly, recursion is strictly more powerful than iteration. Our algorithm like quicksort cannot be expressed naturally with loop only alone without manual managing managing a stack. Uh, a particularly important special case is tail recursion. A recursion is called is a tail called when it is the very last thing the function does. Nothing happen after it return. The GCD function. So here is the classic example because there are no pending operation after the recursive code. The computer can re- recognize this pattern and automatically convert it into an in-place loop using some code. Uh, the eliminate this need the need to pass a new frame onto the code stack for each code, effectively preventing stack overflow for deeply recursive computation.
Okay, next multi-level return exception. Sometimes program list to exit not just two current function but different level of lesson function called as one multi-level return. So this program is cleanly no flash, low programming return value to every level. Common list properties return from for this purpose. Ruby use cast and tell as a successful navigative merchant. Not not that in Ruby. This is not for error handling, but for cleanly existing a successful search or traversal. Exception on the other hand uh, are designed specifically for filler uh, scalar when a function cannot fulfill its contract. When a exception is told the runtime performs such unwinding its system vertically, destroy and force memory from waiting back, though the code stack until it's from a matching cut or except block. This is fundamentally different from a Roman return. Is an emer- emergency exit. Uh, the next uh, continuation continuation are one of the most powerful and attract concept in a programming language trivially and also one of the most mind bending. A continuation capture the entire current equals recursion step of a program as a first class object. This calculates uh, three components. The program counter, uh, where the instruction is the current environment of local variable and re- reversion reversion sets and the full stack backcheck and function code. In a streaming the code function code with current controllation capture is step whenever that continuation is later invoked. The programming instantly the back in time to the track moment. The connotation was correct and remains from there. That is extraordinarily powerfully. It allows you real custom connotation generator generator and even backchecking such algorithm and from a single uh, primitive uh, and strict poetry sequencing uh, all final section cover covers sequencing the most fundamental from a control flow. Let let's look at what is meant and why is it uh, sequencing structure. Sequencing as is called acid to control the order in which time is fixed occur. Uh, if there was no slide effect, the word the one we now need to and for an a particular ex- extension order at on in list and on goes 68 the value of statistical block the value of its last expression. The idea from a theoretical standpoint uh, is even tendency the property that function always returns the same output the new same input with no side effect. This that Eclipse and Turing style language and for and it makes programmers is easier to decision about and correct uh, and methodologically, but side effect and sometimes unavailable. The random number granted run uh, is a perfect system. It is not trained in Poland set on very cool. It didn't. It was returned the same number every time. With the defeat the full force and clearly other type of programmatic with the rule Approximately product style effect on global or statistical variable, but they strongly provided from a differing parameter adapted to frame reference reliability with separately. Thank you for listening, teacher.